Hi, Mr. Ben here. Just want to look at a couple more examples to do with acceleration. So, example 3, we've got a car travelling 100 kilometres per hour, decelerates at 5 metres per second. How long will it take for the car to stop? And then how far does it take to stop? So in other words, how far does it travel in that time? So key information you're probably looking at here when you're looking to highlight some stuff. Obviously that speed there, and then we know it's coming to a stop, so we have to actually work out how long it takes and then how far. Alright, so let's write some stuff down on the side over here. So the car's travelling 100 kilometres an hour. That's going to be the initial velocity. That's equal to 100 kilometres per hour. Now I need to convert that to metres per second, so divide that by 3.6. So 100 divided by 3.6. Now you'll probably get used to these sort of, so that's 27.78. Okay, so that's equal to 27.78 metres per second. Our final velocity is going to be equal to 0 because it's stopping. And we know it's accelerating at, decelerating at 5, and so it's negative 5 metres per second squared because it's deceleration. So we need to find out how far it's going to take to stop, and we also need to work out the time. Okay, so t we don't know, and we don't know s. So the thing is, you've got all these formulas on your formula sheet, so you come up to here and you go, which one's got A, V, V0 and T in it? Well, obviously number 2 does, so I'm going to have to rearrange that, aren't I? So we'll use that first one to find the time. So scroll down here. Alright, so if I rearrange that, T is equal to V take V0 all over A. Okay, so that's going to be equal to 0 take, now 27.78, all divided that by the deceleration with minus 5. So I go on my calculator, I just go divide 5, it's going to give me 5.56. Okay, so that's equal to 5.56 seconds is how long it's going to take to stop. Now, the time it takes to, or the distance it's going to travel in that time, I've got probably some options because I do know a fair bit about this now. So if I just scroll up to the formulas, okay, well, I do want to find this, don't I? Okay, so I do know the time now, and I do know the deceleration, so I could use that formula there, or I could use that formula because I know both the velocities and the accelerations. Now, I'm probably more likely to use this formula here, number 4, because number 5 uses this value t, which I actually don't know if I've done correct. So if I use something which I've done and I've made a mistake, I won't penalise you, but it's probably better to use something that's, you know the values are correct. So 2as is equal to v squared take v0 squared. All right. So obviously to rearrange that, I need to get rid of the 2a. So s is equal to v squared take v0 squared all over 2a, isn't it? So then I can just put the values in that I do know. My final velocity we know is 0. My initial velocity is 27.78 squared, and then that's all over 2 times by negative 5, because that was my deceleration. Now, calculator, you can just do that one step, so not much point doing the 0. So, and I know the 2 negatives are going to cancel out, so let's do 27.78 squared, and then I can just divide that by 10. So that's going to give me 77.17 metres. Okay, so 77.17 metres is the units. So it's a fair way. Alright, so if you're travelling 100 kilometres an hour, deceleration of minus 5 metres per second squared is actually quite a hard deceleration. It's going to take you a fair while to stop. we're certainly going to be looking at some questions like that in class. Right, second example, we've got a missile is launched from a jet fighter travelling at 1200 kilometres per hour and accelerates at 50 metres per second for 3 seconds. So what is the final speed of the missile, and then how far does it travel after launch? Okay, so again, we need to highlight some information. All right, so we've got our acceleration there. We know it's doing it for 3 seconds. We know our initial velocity of the missile there, or the plane. We need to find the final speed, and we need to find out how far does it travel. Okay, so I'm going to again write down some information. So the initial velocity of the missile is in fact the speed of the jet fighter plane, which is going to be 1200 kilometers per hour. So again, I can go to my calculator. 1200, divide that by 3.6 to convert that to meters per second is 33.33. Sort of reminds you of that advert, doesn't it? So divide by 3.6 is 333.33 meters per second. We don't know our final velocity, so we just put a question mark there if we don't know that. Do we know acceleration? Yes, we do know acceleration is positive 50 meters per second squared. We know it's accelerating for 3 seconds. And do we know the distance? No, we don't know the distance, okay, because we actually have to find that. So these are really our things that we possibly want to find. Now, I do have a formula if I go to the top, and rather than me scrolling through, I'll just write it down. V is equal to V0 plus AT, which is the same as the acceleration formula. It's just been rearranged. So that would allow me to work out what my final velocity is. So I put my initial velocity 333.33 plus 50 times by 3. That's going to be 150. So that's going to be 483.33 meters per second. So that's going to be my final velocity of the plane, of the missile, isn't it? Now, to work out the distance it's going to travel in that time period, I do know my initial velocity, and I do know my time, and I do know my acceleration. So I'm thinking you'd probably want to choose this formula here, equals V0t plus a half AT squared. So I put all my values into that formula. So I know my initial velocity is 333.33. I know it's going to accelerate for 3 seconds. My acceleration is going to be a half of 50, and then that's going to be for 3 seconds squared. So again, I go to my calculator and I can put that in and do it in one step. So just clear that. So that's going to be 333.33 times that by 3 plus a half of 50, which is going to be 25, times by 3 squared, which is going to be 9. So that's going to give me 1225 meters. Okay, so that's going to be rounded up to be 1225 meters, which means that in that time it's going to travel 1.225 kilometers. So in 3 seconds it's traveling a fair way, isn't it? Right, so there's 2 simple examples of how to use the formulas that we've got on our formula sheet. So again, the process, it's the problem solving process that you need to develop. So being able to read the question, and then what you need to be able to do is you need to be able to put this information down on the side there. Then what you'll find when you do that is you'll have the information that you do know, and you'll have the things that you want to find. It will be easy then to select the formulas that you actually need to choose. Right, so there's a whole heap of questions for you to actually have a go at in this section. So I'll leave you to have a look at your program and work through those. And we'll be doing that in class time as well. Okay, I'll talk to you in class.